Dude, how do we know the universe is 13.8 billion years old? Well, the universe is expanding, and we know this because when we look at distant galaxies, they're all moving away from us. And the further away a galaxy is, the faster it's moving. Not through space, but with space, as space itself continuously gets bigger.
Alright.
Well, if we run the clock back, the universe would have been denser and denser until at some very distant time in the past, space and time was concentrated into a single point. We can solve for how long ago that was. How? Well, let's walk through it together. First off, we can determine how fast galaxies are moving away through measuring the redshift of their spectra, as well as their distance through what are known as Cepheid variable stars and Type 1a supernovae. These are known as standard candles in astronomy because they shine with a known consistent brightness. This allows us to calculate the mind-numbing distances to the galaxies that they're in.
Okay.
After the distance and velocity of galaxies is understood, you can plot the two graphically and notice that they're linearly related. Again, the further away the galaxy, the faster it's moving. Velocity is proportional to distance. The gradient or slope of this line is the average recession rate of galaxies, and it's known as Hubble's constant. It turns our proportion into a useful equation, known as Hubble's law.
Ooh.
Now, the precise value of Hubble's constant still needs refinement, as the various methods used to measure it still disagree to a level that cosmologists aren't entirely comfortable with. Noteworthy too is that it changes over time, so it's not really constant. For our purposes, we'll just go with the value of 70 kilometers per second per megaparsec, the middle ground for what's been experimentally measured.
Okay. You said mega what?
Megaparsec. Just know for now that it's a vast measurement of distance equal to over 3 million light years. For every megaparsec, galaxies are receding away about 70 kilometers per second faster.
Alright.
Hubble's law is incredibly useful for a variety of reasons. For now, we'll just use it to find the age of the universe.
Moment of truth.
So, given that the whole universe was together at one point, how long would it take a galaxy to reach its current distance from us given its current velocity? Well, we can rearrange the equation, dividing both sides by Hubble's constant and then both sides by velocity. 1 over Hubble's constant is equal to distance over velocity, and d over v is time. The age of the universe turns out to be the inverse of Hubble's constant, whose value we can plug in after converting it into the proper units, and we wind up with this number in seconds, which is equal to about 14 billion years. Voila, the age of the cosmos. Cosmologists are able to refine this number to the more precise 13.8 billion years after using math a bit more complicated and taking into account the total energy composition of the universe. But how incredible is it that such a simple equation can yield such a profound result?
Yeah. Can you repeat, everything you said?